Hello there. Today we are going to start off with the fourth class of the chapter sequence and series. And in this class, we are going to discuss the second part of geometric progression. Now, specifically, that is the sum of a geometric series. Now, to begin with, same as that of the arithmetic progression, the sum of n terms, the first n terms of a geometric progression is denoted by Sn and is defined by Sn is equals to a into 1 minus r to the power n by 1 minus r, and when r is not equals to 1. Obviously, if r becomes equals to 1, then it does not remain a geometric series. It will become a constant series. So therefore, r can take any value but not 1. And the same thing can be written as a minus r an by 1 minus r. Now let me explain this, how this comes. Now an means what? An means a r to the power n minus 1. Now if you multiply r to this, then r times an, that becomes a r to the power n, right? So a minus r an, that is basically a minus a r to the power n. So that can be written as a into 1 minus r to the power n. So basically I'm just rewriting the same thing in a different way, but this formula is particularly useful if I know the first term and the nth term of the sequence or the series whose sum I'm trying to find out. Fine. So these are the two main formulas which we are going to make use of. Now there is something more to this, and that is sum of an infinite GP. Infinite GP means if a GP goes on to infinity, and if we are trying to find out the sum, then what is going to be the formula? The formula is going to be a by 1 minus r. Now here this is something which is very important, we all need to take care of. The value of r, that is the common ratio, must lie within 1. That means the value of r should be minus 1 less r less 1. So if I don't have the value of the common ratio within this limit, then what happens? If I'm trying to think of an infinite GP, we won't be able to think of obviously we can think of an infinite GP, but trying to find the sum of an infinite GP won't be possible. Why? Because if r goes more than 1 or less than minus 1, then higher powers of r will be large, and so you won't be getting a fixed sum. The sum will tend to infinity. So to ensure that you have a sum, you get a value of the sum, then r must be between minus 1 and 1 so that it converges to a particular sum. That is a very heavy word to use, converge. Anyway, now this is it, exactly what we need to solve the problems in this class. So let us just begin. The first one. Find the sum of 6 terms of the sequence 1, minus 2 by 3, 4 by 9, and so on. So all I need first is the value of a, value of r, that is the first term and the common ratio. And also it is told that sum of 6 terms, so value of n is 6. So therefore, if we put it all in the formula and calculate, we get the value this 133 by 243. Just check your calculation, do it once all by yourself. I'm sure you'll get it. Number 2. Find the sum of the infinite series 7 minus 1 plus 1 by 7 minus 1 by 49 and so on. So the first term here is 7, here the common ratio is minus 1 by 7, and that's all you require, because as it is an infinite series, you don't need the value of n. So the formula for finding sum of an infinite series is a by 1 minus r, and once again let me just tell you that see the value of r, the value of r is less than 1 or minus 1. It is between 1 and minus 1. So that's the indication that you can actually expect a infinite sum of this particular series. Now Just put the formula and calculate, and so this is your answer. Right? Let us move to number 3. If the nth term of a GP is 128 and the sum of its n terms is 255, if its common ratio is 2, then find the first term. So almost everything is given. All you need to do is put everything in the formula and calculate. So first term, let it be A. So given that the common ratio is 2 and it is given the nth term is 128 and sum up to first n terms is 255. So Sn is given to be 255. So all these informations are given. Now let us put it into the formula. Now, what is the formula? Here you see, I know the last term, I need to find the first term. So in this case, all I can do is make use of the other formula, that is A minus R An by 1 minus R. So except A, all the values are known. So let us put it and do our calculation. And upon doing the calculation, you get the value of A as 1. Right? Let us move to number 4. If the sum of first 6 terms of any GP is 9 times the sum of the first 3 terms, then find the common ratio. So sum of first 6 term is 9 times the sum of first 3 terms. So how does it look like? It looks like something like this. So S6 is equals to 9 times S3. Now let us put the formula of S6 and S3. This is how it looks. Now 1 minus R and 1 minus R in the denominator, you can cancel it out. Why? You can cancel these two out because R can never assume the value 1. So therefore R is not 1. You are sure. So that is not contributing to the equation. So you can just strike it off. Next, you have this. Also you can cancel out A and all those things which can be cancelled out. Now 1 minus R to the power 6 can be written as 1 plus R cube into 1 minus R cube. Now once again you see you can cancel this one and this one out. Why? For the same reason that R can't be equals to 1. So therefore all you are left with 1 plus R cube equals to 9, and that gives you R cube equals to 8. So R is 2. Fine. So that is our answer. And please ensure you mention this, that R is not equals to 1. Now you should have mentioned it here as well, that R is not equals to 1. 2 places you need to mention, obviously, because why you are cancelling it out, R could have taken the value 1, but as R can't take the value 1, so you are cancelling it out. So please ensure you mention it. Number 5. If second term of a GP is 2 and the sum to infinity is 8, find the common ratio. Second term of a GP, so what is second term? Second term is basically A2, or that is AR. So AR is given 2, so from there I can write A is equals to 2 by R. I'm just finding this relation between A and R. And sum to infinity is given 8. So therefore A by 1 minus R is equals to 8. Now you can replace A. You can replace A, or first you can take it on the other side, and now you can replace A by 2 by R. So that gives you an equation, a quadratic equation rather, 4R square minus 4R plus 1 equals to 0. From there you can actually find the value of R, and the value of R is half. Now you could have written plus minus half. No problem with that, because even if it is minus half, that then also it satisfies the equation. Okay, let us move to the next problem. Find the sum of the series 7 plus 77 plus 777 up to n terms. Now this is a very common question which is done in your class 10. So let us just recap the whole process. So we start off with this, then take 7 common out, then divide by 9 and multiply by 9. So you get this 9 plus 99 plus 999. 9 can be written as 10 minus 1, 99 can be written as 100 minus 1, 999 can be written as 1000 minus 1, and so on. So you have two different series actually. One is 10, 100, 1000, which is a GP series, and then another constant series, all of 1. So in this one, the first term is 10, common ratio is 10, and here the sum of all ones up to n terms, that gives you n only. So now just put it into the formula and do your calculation, and then you get the value this. So this is the sum till n terms to this particular series. Okay, now let us move to number 7. The sum of an infinite GP is 16 and the sum of the square of its terms is 153 by 5. Find the common ratio and fourth term of the progression. So this is given sum of to infinity, that is a by 1 minus r, that is equals to 16. So from there you can find a relation between a and r, and again sum of the squares of each and every single term, that is given 153 3 by 5. So here the first term is a square, common ratio is r square, so a square by 1 minus r square. So all you need to do is from these two equations you have to solve and find the value of a and r. And so if you just go on doing your calculation, you get the value of r as 1 by 4. Fine. Now obviously there is another part to the same question, that is find the fourth term of the progression. I'm pretty sure you can do it by finding a and then finding the fourth term. So I have left that for you to do it. So I'm just even writing it. All you need to do is find a and then you need to find the fourth term. Fine. So just try yourself. Fine. That's it. So that's our class. Hope you have understood, and as always, if you have any doubt, please get it clarified. Thank you.